For our lesson today, we're going to talk about combining functions symbolically. We're going to focus on addition, subtraction, and multiplication in this lesson. We'll hold off for division in Module 2. But when we look at combining functions, we're just adding or subtracting or multiplying the functions together and then seeing what happens to the resulting domain. So algebraically, we're going to see two functions, and they may be different types of parent functions, but we're going to try to combine and simplify as best we can. So when we combine, it says f plus g. All we're doing is f of x plus g of x. So if I take that f function, let's rewrite this right here, but so if I take that f function, it's the square root of x minus 2, and we're adding the g function, which is square root of 7 minus x. Now with square roots, we can't add the square roots together or simplify them further unless the inside is the same. So I wouldn't be able to condense that down any further. But we can look at the domain of this function. So if I think about this domain, I need to consider what is the domain of f separately and what is the domain of g separately. So when we look at f, it was the square root of x minus 2. And we've talked about when you have a square root, the inside has to be greater than or equal to 0. So if I simplify that, I get x is greater than or equal to 2, which means the domain would be bracket 2 to infinity. And then we look at g, which is x, or 7 minus x, on the inside. So I would solve that one out. Here, let me put a little divider here. So let's subtract subtract 7 from both sides. That gives me a negative 7. And then we can divide by a negative 1. Hopefully you remember when we divide by a negative, we have to flip our inequality sign. So when I divided both sides by negative 1, I did get a positive 7, but that also flips the inequality. So now this is going to be negative infinity all the way up until 7. And so if we have combined our functions together, we want to look at what is the resulting domain of that function. So the domain of f plus g. And if I look at the overlap between those, sometimes it's helpful to consider a number line. So I'm going to take that and graph the first one. So it would be 2 bracket all the way to infinity. So it would just go up to the right. And then if we did 7, it would be a closed circle at 7 and shaded to the left. So when we see the overlap, what's happening is right here in this middle is the overlap section. So our domain would be bracket 2 all the way to 7, closing bracket there. For number 2, we have a quadratic function and another quadratic function. So we're going to compute f minus g. And when we're doing subtraction, I usually put parentheses around both parts, and we'll see why here in a second. But this would be f minus g. And I put the parentheses around this mainly because I want the parentheses around the second part. We are subtracting this whole thing, not just one number, we're subtracting the whole thing, which means I'm going to have to distribute this subtraction. So if I simplify this further, I'd have x squared minus 5x plus 3, there's our f, minus 2x squared plus 11x, because we're subtracting a negative, and then plus 14. And then we combine like terms. So if I combine x squared and negative 2x squared, I end up with a negative x squared. Negative 5x plus 11x leaves me with positive 6x. And then positive 3 and positive 14 is 17. So here's our resulting function. We ended with a quadratic, but we have to look at the beginning. So I'm going to go to what is the domain of f, and it is a quadratic function. those have no restrictions. Therefore, our domain is negative infinity to positive infinity. The domain of G is also quadratic, so therefore it's all real numbers, or negative infinity to positive infinity. So basically just the overlap of those two would be the domain of f minus g is still negative infinity to positive infinity. Let's just note down here, this is what we're talking about, f minus g. And the third one, we're doing f times g. So notice there's not a multiplication dot or symbol, but the letters are beside each other. So that's just indicating multiplication. So we're going to compute f times g to give us parentheses negative 8x plus 9 times 3x minus 2. And you do want to put those in parentheses because you're multiplying those. And if I distribute, we're distributing two binomials here, so negative 8x times 3x is negative 24x squared. Negative 8x times negative 2 is a positive 16x. 9 times 3x is 27x. And 9 times negative 2 is negative 18. Again, we want to combine like terms. So I would start with our quadratic piece, so negative 24x squared. Then go on to the linear terms, 16x and 27x. 16 and 27 is 43, so 43x. And then negative 18 is the only constant. So f times g of x ends up simplifying all the way to this expression. Again, we want to look at that domain, so let's start at the beginning, domain of f. The domain of f was linear, which is all real numbers, or negative infinity to positive infinity. The domain of g, also linear, so still negative infinity to positive infinity. And the overlap of those two stays the same, so the domain of fg is negative infinity to positive infinity. In number 4, we have a rational function and a quadratic. So I'm going to take that f minus g. Here we go. So f is 4x minus 1 over x plus 2. And we're subtracting x squared minus 25. So remember, when I'm subtracting more than one thing. I want to put parentheses there. So I'm subtracting x squared and negative 25, which would leave me with 4x minus 1 over x plus 2 minus x squared plus 25. And that's all we can do right now. We're going to talk about how do we combine rational functions, how do we add and subtract rational functions in Module 4. But for right now, we're just focused on looking at what that would subtract to be, and mainly the domain of the function. So here's the important part in this function. The domain of f was rational, which told us the denominator cannot equal 0. So if I know that the denominator cannot equal 0, then x plus 2 cannot be 0. And if I solve for x, x cannot equal negative 2. So our domain would be negative infinity all the way up to negative 2, union negative 2 to infinity. The domain of g is all real numbers because it's a quadratic. So it's saying any value we want. So the overlap of those is saying we're still going to take out negative 2. We can't include it. So the domain of f minus g here is negative infinity to negative 2, union negative 2 to infinity. On the second page, we're going to see these evaluating parts. So I'm going to evaluate the function f and g, and it says f plus g of 6. So just remember what this meant. F plus g of x was just f of x plus g of x. So we're doing f of 6 plus g of 6. So we're just going to evaluate separately and then combine. So let's determine what those are. I'll do that f of 6 first to get 6 squared minus 11. That's 36 minus 11, which gives us 25. And then we plug in g of x, or sorry, g of 6. So square root of 4 times 6 plus 1 is the square root of 24 plus 1 is 25. And the square root of 25 is 5. So when we combine, we're doing f of 6 was 25 plus g of 6 was 5. So when I get that, I end up with 30 as my answer. 2, we have a function h and a function m. We want to evaluate hm of 3. So again, just notation-wise, this would be h of 3 times m of 3. Now I'll plug that in. So h of 3 would say negative 2/3 of 3 minus 7. And you can use your calculator to plug that in, or you can kind of just multiply that out. But I would end up with negative 2 minus 7, which is negative 9. And then we find m of 3. So that would be 2 to the 3rd, x is an exponent, minus 5 times 3. We have another x in that equation. 2 to the 3rd is 8, so 8 minus 15 is negative 7. So I have a negative 9 and a negative 7. When I evaluated this, h of 3, that's negative 9, negative 7, m of 3. So together, negative 9 times negative 7 is a positive 63. The last one here in our notes is f of x and g of x graphically, and we want to evaluate f minus g of 1. So again, I'll just write that out in a different notation, f of 1 minus g of 1. So if I find f of 1, what that's saying is when x is 1, what is y on the f function? So here's our f function, this quadratic or this parabola. So I'm going to evaluate it, and f of 1 ends up being up here at 7. We'll do the same thing for g of 1. Our g of x function is this linear function. So g of 1 is down here at negative 3. So f of 1 was 7. G of 1 is negative 3. And we're subtracting, so we're saying 7 minus negative 3, which ends up being plus because minus a negative, but we get 10 as our result. Okay, the last part is just a couple of questions for you to try. You've got some here on the rest of this page and then the next page. In the second video, you can check your answers to see if you understood what you were doing.